Hello, good afternoon, I guess. Welcome to Big MiniConf, our 7th Big MiniConf. And our speakers today are our lovely students who are currently taking our 12-week immersive course. And let's give them a round of applause. And so, as an appetizer, we have Genta Shibasaki talking about using Electron to create a cross-platform desktop application. Let us welcome Genta.
Okay, wait for a minute. Okay, so thank you for coming here today. Today I'd like to talk about using Electron to create a cross-platform application. So before starting my presentation, I'd like to talk about myself a little bit. Okay, my name is Genta Shibasaki, as you saw at the first slide of my presentation. And also my career and personal history. I worked as a team leader in a manufacturing company in Japan for 8 years. So yeah, I managed a budget and schedule to meet the deadline and did quality control, and also yeah, I did the whole management things. And now I'm in code research to learn how to create an application from scratch. And also my hobby is drinking. So because so I love drinking because we can talk each other more openly. But there's a problem, so I think I got a little bit of beer belly, so I might have to go on a diet. Okay, that's enough. Okay, then so what is Electron? So Electron is an open source framework. And also, if you are interested in it, so you can see sources and so active share on GitHub whenever you want. And also, Electron can create desktop applications by using JavaScript, HTML, CSS only. So the reason why Electron can create desktop applications by using them is to Electron wrap the OS native APIs. And you can call those APIs using JavaScript. That's why you can create desktop applications using Electron. Okay, also Electron can use Node.js APIs, so like file system API, and also Node.js modules. So it's famous for like Angular and React and Vue. Okay, so that means you can create complicated applications without much more effort. So because, and also you can, those modules accelerate and also improve your team's efficiency. But what are desktop applications anyway? So okay, desktop apps run standalone in a computer, so user's computer. So also there are so many desktop applications here, like a VS Code and Slack and Atom and etc. And these desktop applications are made by Electron and Slack, so which and Atom and etc. Okay, next I'd like to talk about web apps and versus desktop apps. Firstly, there's a web apps. So web apps, you don't need to install these applications. So if you have a browser, you can access these applications in no time. But so you need to have access to internet. If you have a bad connections, the response from the web applications is so bad, I think. And basically, web applications cannot access OS native APIs because of the security reasons. So browsers are restricted to access OS native APIs. Whereas here's a desktop apps. So desktop apps are created by various design patterns. That means, so say for instance, so Windows OS, so languages are like a C#, C++, and Visual Studio Code, and also framework is .NET framework is a very famous framework, I think, and also Mac OS language is Objective-C, and so framework is a cohort. So each framework and each languages has its own design patterns. So you have to learn each patterns, and so that means so it might take a lot of time to learn all of them. But so desktop applications, so using those languages and frameworks, so you can access OSNet APIs. That means so you can create more flexible applications if you want. But desktop applications, you have to install and update those apps. So you have to notify users to update those desktop applications. So that means, yeah, it might take some amount of time, I think. It is one of that point of desktop applications. Okay, but why desktop applications? These days, computers like so users uses, so the performance of computers is getting better and better. So that means so developers and so yeah don't need to consider about the performance much. Yeah, and also visibility. You can put those desktop applications. So say for instance, so Windows, you can put them the Windows Start menu, and also you can put them on this Mac OS dock. You can put them, and also yeah, the amount of time of using it. Yeah, I read about the article that said so users using desktop applications, so the amount of times 34% more than web applications. So that means so you want users to use your applications. Why don't you use your application as a desktop application? Okay, the next, why Electron? I think there are 4 reasons. Okay, the first is the popularity of JavaScript and HTML and CSS. And the second part is the first development. And the third part, automatically update apps. And the last point is so be able to create cross-platform apps. Yeah, I'd like to talk about each point in detail. The first point is the popularity of JavaScript, HTML, and CSS. So as you can see, there's a graph here. So it's based on the Stack Overflow 2020. So yeah, this is the most there is the most famous language is JavaScript, and the second place is HTML, and the third place is CSS. So that means so there are a lot of developers who can use those kind of languages. And also first development. So as I mentioned, so there are a lot of developers and so who can use those kind of language. That means so you don't. I think so you don't have to much more effort so to get developers, and so also I think so using Electron is faster than using other frameworks. Also, automatically update apps. That means so Electron has a auto update modules. So this module, so if users install apps, so using Electron, so if you open the apps, users open apps, so this application so will be updated automatically. So you don't have to notify users to update your applications. So it is a good way, it is a great one point, I think. Then also the last point is, so you can create a cross-platform applications. So there's a Windows, Mac OS, and Linux. So if you want to create desktop applications, you have to learn Windows language and frameworks, so Mac OS and Linux, so each language and each frameworks. But if you are using Electron, you don't have to learn all of languages and all of frameworks. So which is pretty nice, I think. Okay. Then vice versa, so why not Electron? I think there are two reasons. First, yeah, it might take a lot of storage and random access memory. Also, the second part is, so you should take care of security. Okay, the first one is here. Okay, Electron application, so might take 500 megabytes or more, including updater. Okay, for example, so VS Code. So VS Code asks you about like 800 megabytes of storage. So yeah, which is pretty huge, I think. Also, random access memory. So yeah, in terms of Slack desktop applications, if you open this application, so 300 to 400 megabyte random access memory is taken. So yeah, this is also a little bit huge amount. Okay, the second point, you should take out security. So Electron can use Node.js APIs, as I said. So Node.js APIs are including file system API. Okay, file system API can gives you a right to access all files on the computer. So if hackers can use those APIs, that means hackers can access all of your files on the computer. But no need to worry, so don't need to worry too much, because there is a security rules on the firmware page of Electron. So we can follow the rules, and so we can prevent it like this. Okay. The next part is, how does Electron work? Okay. Electron create a main process first, and the next. So main process create renderer process. So renderer process uses Chromium open source. So Chromium is open source, and so that is using Chrome browser, and that is from Google. Then after that, you can use applications. Okay. I'd like to show how to use Electron. Okay, here is my directory, and I create a directory for Electron. Okay, then change directory to Electron. Then create a first project file here, and you can call you can add Electron. But Electron a little bit huge. Please wait for a minute, a little bit. I'm sorry. Okay, I'm installing now. And you can call the Electron here. Okay. Here's the Electron application here. Okay, then next, I'd like to show my demo application, and I created it in 2 days. So this is a chat application. Then here is a authentication feature. So you put email address, and there's a personal phone. Okay, this is my account. Then I can log in. Then you can see, so here's a chat room here. Then here's a logout button. Then if you click here, you can see there's so messages. And also here's another account here. So this user can see the same messages here. If I put the messages here, like so how about soba noodle, today's lunch. So yeah, I posted here, then so other users can see my post. Then also, other user, it sounds late. I'm sorry. Okay. Yeah. Press first. So other user can post it, and my account can see their post here. Also, if you want to create another chat room, you can create a chat room here, like okay, dinner. Yeah, here's a dinner room. Then I can also see the dinner room here. Then you can start a conversation in dinner chat room. Yeah. This is a chat application, so using Electron. Okay, the next I'd like to talk about the future of Electron. I think the future of Electron is bright, because Electron joined the OpenJS Foundation last year, December. So the OpenJS Foundation runs Node.js project and also Webpack project and other projects. So that means, yeah, I think Electron bond with Node.js and Webpacks more strictly, and also Electron can grow bigger in the future, I think. And also Electron means demand these days. I mean, users demand are changing every single day. That means, yeah, I think we might have to create applications faster. Yeah. Then Electron gives us the power to create applications faster than other frameworks, I think. Okay, in conclusion, yeah, I think Electron has some downsides actually, but it has some upsides as well. Also, with web technology skill you have and want to create desktop applications, Electron would be the great choice. And the last but not least, Electron to become more powerful framework, as I said, because this joined the OpenJS Foundation. Okay. Thank you. Here's my info. So if you're interested in my apps, please scan the QR code. And here's my GitHub account and LinkedIn account here. So thank you very much. So thank you for listening to my presentation. That's it. Thank you.
Before we resume, we will take a 10-minute break, and we will resume at 1:30. All of our speakers today are students who are taking our 12-week immersive course. And now they just finished week 8, and they will be presenting their tech talk. And next we have Kasumi Nakano talking about getting started with API and IoT.
Thank you. Good afternoon, everyone. My theme for today is getting started with APIs and IoT. This is today's outline. Firstly, I'm going to talk about me, and next, I'll talk about air quality, and then what APIs are. Finally, conclusion. Before talking about APIs, I'll introduce a little bit. I'm Kasumi. I was born and grown up Kansai area, Shiga, Osaka, Kobe. And I majored in electronic engineering and studied about electromagnetic surveying method like EMC. At that time, the transistors and converters fascinated me a lot than boys. After I graduated university, I worked for 6 years as an engineer of production technology department at domestic company. I used a lot of tools, one of users so far. So thanks to smart and useful software tools, I studied and worked efficiently. That made me to decide to be a software engineer next when I thought about changing my career. So I'm here today. I'd like to talk about the air quality next. I have a question. Do you guys pay attention to the air quality? If yes, please raise your hand. Oh, a lot of people. I'm happy to know that things. As you guys already know that the air quality is very important to our comfortability. Regardless relaxing, working, and studying, and also sleeping. So comfortability is the most important factor of our lives. I learned comfortability is strongly related to our productivity a lot through previous jobs. My previous job were mainly to design the production lines or factories, and also to improve the production efficiency by modifying the production line. So from that experiences, I learned about how comfortability influenced the person's productivity. So that's why I'm still aware of air quality in the room. Air quality is composed mainly 3 essential elements. First of all, you already know that temperature. It is impossible to work without AC even though inside the building. We cannot say that too hot room or too cold room is good place to work. And also too humid or too dry atmosphere might make us in bad shape. So as for those 2 factors, we can realize by ourselves easily, and also we can fix it by ourselves. Just turn on AC or using using some home appliances. Sorry. So last one of main elements is the amount of carbon dioxide. It is difficult to realize by ourselves, but generally speaking, it should be under 1000 ppm inside the room. It is said that people feel tired when it's over 1000 ppm. When it turns to over 3000 ppm, people feel airless. And if becoming over 5000 ppm, it endangers people's lives. To keep the amount of carbon dioxide under the 1000 ppm is also important to our health and productivity. So that I decided to create the application this time, which I can check the air quality. I'm gathering my room's information by using this weather station. This weather station is called Smart Weather Station and produced at the Net Atom company from France. And using this sensor, I can get full data: temperature, humidity, the amount of carbon dioxide, and the noise level. Each every 5 minutes. To create this air check application, I retrieved the 3 important data: temperature, humidity, and the amount of carbon dioxide from it by using APIs. Before moving to talk about applications, I'm going to talk about what APIs are next. API stands for Application Programming Interface. The API exposes some of its software so that its functions can be shared with other software. By releasing part of software on the web, anyone can use it from outside. This allows us to embed other functions in your software so that applications can work together. Before sharing APIs on the web, the companies had to gather all data to create a new application each time. To collect data needs a long time and a lot of effort. Nevertheless, that data was used only for one application or only for one company. It made application development cost higher. Since APIs have been sharing, it has been much easier to use the data of outside than conventional closed development to create a new application. This also allows us to combine the several data easily. API's ecosystem is also growing as web APIs have been shared. The several services have started that gather APIs and provide them to users with a single standard as gateways. For instance, Rakuten Group started the API Marketplace service, Rakuten Rapid APIs, like that. After APIs turned to share, because it is possible to use and combine the several data from outside, companies don't need to gather all data by themselves only for an application, so that they can create more new services for their customers with a lower cost than before. In addition, as companies open that data that companies create by taking time, the data is turned to be taken advantage of more. Developers can reduce man-hour cost to create new applications by using APIs. For instance, let's think about creating weather application. When don't use APIs, First of all, developers have to create and gather the information first, and create two databases with a database and a location database. And then should program to retrieve the data that we need from database each time. Otherwise, if using APIs, we just retrieve the data from APIs like Open Weather Map and Google Map. We are able to use APIs which are already created and opened instead of working for backend. We can get a lot of APIs which a lot of companies have already opened. For example, Microsoft provide APIs that we can use Office 365 or facial recognition and so on. Google opened their APIs that we are able to access Google Map, Google Document, etc. We can also use social media's APIs. The importance of home automation control and home electronic management system have been recognized. IoT gadgets and home appliances are commoditized these days. At first, companies tried to create their own application and were passive to open their data. However, the demand from users made them move to open it on the web. More and more companies are also starting to open their products' APIs. The customers can get and use more personalized applications which are created by using those APIs. This can make their lives more comfortable, I believe. So let's take a look at an example. The company which produce and sell my favorite air cleaner Sharp, it also started to open their products APIs. It makes us be able to add the function into our home energy management system that can check if air is clean enough or not. If our hands can get the information of the air quality, it operates home appliances automatically to create comfortable air for me. So I talked the advantage to using APIs so far. Of course, there are some risks too. Firstly, apps which created by using APIs is relying on the data from outside. It means that if their APIs are stopped to open anymore or changed by providers, those apps can maintain themselves no longer. Secondly, it has higher risk about leaking the data. Even though they're requiring the faces to authentication and access token to access the data, the risks of leaking the data by attacks or accidents are higher than conventional closed development. As user information leakage from Facebook API before, there is still the possibility of being exposed the data to outside with unexpected way. So I'd like to use useful these APIs more with a knowledge about those risks. Now I'll show you the application to check the air quality for my room. A little bit small, but okay. This is the application of air checker I created. And firstly, I'll select the action of the moment, and because this each action has proper temperature, so we can set each by choosing my action, I can set proper temperature, and there is current information of my room, temperature, humidity, and the amount of carbon dioxide. And the bottom's three icons are my room's current situation. This is temperature. This icon means too cold at the moment, and this icon is about humidity. My room is too dry now. And the last icon is the amount of carbon dioxide. My room hasn't too much carbon dioxide at the moment, so it's clean. So this is the application I created for checking air quality now. So going back to my presentation. So I created that application with JavaScript, Vue.js, ArcGIS, Express, and Bootstrap Vue other than APIs. That application is just one way to use APIs and IoT tech. In conclusion, as more and more APIs and IoT tools are put them together, so our smart society will become more comfortable in the near future. So that will be all. Thank you for listening.
Once again, thank you very much, Kasumi. And if you care about air quality, if you want to boost your productivity, feel free to talk to her after this. And we will now take a break and we will resume at 2 p.m. Thank you very much. 2 p.m. Next on, we have AI in photography and editing software, brought to you by Khan from Germany. Thank you, welcome.
Alright, good afternoon everyone, friends, new friends, family, everyone at home watching on live stream. My name is Khan. I'll talk to you about AI in photography today. Is there anyone in this room who likes photography? Is there anyone in this room who hates photography? Alright, otherwise you're in the wrong room, okay? This is good. Next, I'd like to go over quickly. Hold on, the screen might be freeze. Let me just try to change it. Just 1 second. Okay. Oops. Just bear with me. I cannot move this thing. Okay, sorry about that. There's a bit of technical issue. Quickly, this is the outline for today. As you may know, there are many aspects of AI in photography. We will focus on AI camera and AI in editing software since we don't have 3 hours today. So, quick introduction about myself. I'm from Thailand. I also had an opportunity to attend high school in New Zealand, and later on I came to Japan on a scholarship program provided by Panasonic International Foundation to study my master's degree here. Professionally, I had a lot of experience in human resources assessment and recruiting. I'm also a professional photographer. And now I'm doing a software engineering course at Chrysalis, the best bootcamp in the world. Fun facts. Do you know how many photos were taken every year? 1980, 25 billion photos were taken that year. Not too bad. 1990, we took 57 billion photos that year. Getting better. 2000, 80 billion photos. Just a note here. In 1999, Canon, Nikon, one of them, actually introduced the first commercial digital camera. So from the year 2000 onward, it's like the beginning of digital photography. 2010, 300 billion photos, a sharp rise. Also, Facebook was introduced in 2004, which also contributed to the number of photos taken. Guess what? By the end of 2018, oh my goodness. Congratulations, everyone. You contribute to 1.2 trillion photos. That's a lot of photos and a lot of zeros. Part of it is due to the boom of smartphones. Where everyone has an easy access to the social media by using your smartphone. So basically, just anyone, everyone, take photo anytime, anywhere. Why does it matter? Because now, in 2019, the digital photography market size is about 70 to 80 billion US dollars. By 2026, it is anticipated to double to about 140 to 150 million dollars. So as the market grows, the industry grows, there will be more job opportunities. It's not only for hobby photography, but also other applications. For example, healthcare. Because of AI camera and imaging technology, it helps doctors to analyze patients quicker to save life. Also, security matters. For example, police in China, they are testing. They have this very cool AI-powered sunglasses that actually equipped with the criminal record. So if they look at you, for example, this gentleman, they're like, oh, this person has a criminal record. So they can identify him right away. Just an example. He's a very nice man. So, all right. Moving on, I want to talk a little bit about the current and recent advancement of cameras. Now there are three things that most traditional camera makers are focusing on. Camera, obviously, lens, and sensor. Of course, in order to make better lens, better sensor, you could come up with larger lens, larger sensors. But it's not likely, because at this age, you don't want to carry like this size of camera or smartphone, right? Yeah, you have to put it on the backpack and go somewhere. So that's the challenge. How do you advance those kind of technology in a smaller setup? Therefore, they are focusing on the camera and AI. For example, in terms of smartphone, Apple, Google, Samsung, you can name them. Most of them have pretty similar technologies in terms of the camera itself, the lens, or the outside that I would say more or less like commodities. But what matters is, in case of Apple, they are trying to customize the chipset that they use in the phone. And within this chipset, there's a special portion called the neural engine, which is reserved for AI, artificial intelligence tasks. So this neural engine is a magician. So it determines whether the photo you take is really good, is so-so. So this is why it leads that the future is code, because everything else is commodity. How do you compete against other brands? How do you advance your product? It goes into the software, which is that magician I was talking about, which later I will demonstrate in the later slide how it works in a simple. A bit of fun fact and also case study about the traditional camera makers versus smartphone. You could argue with me. Khan, why are you comparing camera and smartphone? It's like comparing a microwave to a car. But I have a set of data that it's pretty relevant, and we'll see what happened. So this is a graph of the worldwide shipment of cameras from 1951 until 2018. For 60 years, from 1950 to 2010, the traditional camera makers were in a healthy business. They reached the peak in 2010 with 121 million cameras sold. A note here, in 2008, the touchscreen smartphone was introduced. 2010, it was Instagram. We'll see what happened. After 2010, you can see a sharp drop here. It was dropped by 84%. Part of this, or mostly all of it, was from a steep decline of sales of camera with built-in lens, which usually used by casual photographer. And now, a lot of people switch to smartphone. Quick tip here, don't give your camera to a monkey. They won't do good. And unexpected competition. When the smartphone was introduced to the market in 2008, the camera makers, they were doing fine. They didn't see that there was a huge risk coming. The traditional camera maker were focusing on stuff like image stability and all like the sideline feature. They didn't dig too much into like AI and how software really can turn it upside down. This is what happened. When they intersect, according to the graph, in about 2011, that's where smartphone and camera sale met for the first time. After that, it was a totally different story. Smartphone reached the peak in around 2016, 2017 with 1.2 billion smartphones sold versus 121 million cameras sold during the peak. Back then, in 2008, the camera on smartphones were no match to the digital camera. The image quality sucks. But soon after, because of the advanced development of AI, the camera on smartphone could match the traditional digital camera, especially in two areas. First, in terms of depth of field, and second, the low light performance. Those are the game changers. All right. Also, another graph to demonstrate that. This is a data from Flickr. It's a photo sharing platform. As you can see the graph here, about 50% of photos uploaded by user were from smartphone. And also the camera brand that hobby and pro photographers use, apparently, is Apple with 54%. So you can see who's dominating the game here. You can take a guess. One of these photos was taken by an iPhone 11 Pro, and one was taken by Canon 5D Mark IV, which is a top-line professional grade made by Canon. Which one do you think was taken by an iPhone? Come on, it's so obvious. Any guess?
Number one.
One? One? Okay. Two? It's number one. To be honest, there's no difference. I cannot tell. To be honest, it gets to the point that it's so close that even a pro photographer cannot really see. I have to be honest. I use a microscope to see it. Second, one of these was taken by Google phone. Another one was taken by Canon 80D or something like that. Number one for Google. Number two for Google. Why?
Don't like performance.
Exactly. The Google Night Sight offer an amazing low light performance. So these two slides actually demonstrated how smartphones really catch up in terms of depth of field, low light performance. It's not even competing, they already surpass it, right? Wait a minute, what's AI? So in a broad term, AI is a branch of computer science that tries to teach computer to think, learn, and behave like human. But instead of simply being coded to do a particular job, AI camera device are actually programmed in such a way that it learns and also adapt to the user behavior and pattern. To elaborate a little bit more, heavy lifting is the key. The AI knows the camera setting, it knows the image processing, it knows about white balance, aperture. I don't know what those mean. As a user, I want to take a great photo to show my friend, to show my grandma, to make myself proud. I don't care about all the setup. So when you point the camera from your smartphone at the scene, the AI behind that will automatically tweak the setting. It will make sure that you get the best killer shot with the lighting, with the cool filter effect. It does the what we call automatic scene recognition. It's a more complicated method than what it sounds like, but for example, all those like color enhancement, skin tone smoothing, is all like AI work. That's why when you take photo with different phone, you might see yourself look a bit different. Because each phone is programmed or coded differently. Google may have their sort of code that they want to make people look like. Apple will do sort of different thing. I will show a bit of code in a minute. Also, the machine learning. The smartphone maker actually use this machine learning technique to develop the image recognition, which make use of like that neural engine, the magician I talked about. It trained the machine to see like millions of images, so that the machine can look for the visual clues at the pixel level. And as time progresses, the algorithm gets better and better in recognizing objects and the scene. The second point, you might have heard about this, a lot of people are talking about it, computational photography. What it means, like, it refers to the digital image capture or processing technique that use digital computation instead of optical process. So it's optical versus computational. For example, if you own Apple iPhone 11 Pro, Sorry, I'm not selling Apple here. I think it's an obvious example. So I like to use it. It has a lot of camera. I don't know how many, was it 2 or 3? These camera, they don't just stay there. They actually communicate with each other. When you take photos, maybe one lens communicates with another lens. It passes the image data to the next lens, enhance the data, pass it to the next one. And then as a user, you get this amazing result. That is not possible with the optical process without computational. Google, the Pixel Night site, work pretty much the same way. It stacks a lot of images in one scene. When you take photo at night, I think it goes up to about 15 frames, and then they stack it up. They pull the shadow from one photo, they pull the highlight from another photo. Boom, you get one perfect night photo. That's computation photography. Just a quick code to demonstrate. Computational photography is about transforming the image using algorithm. So it's like a set of routine that the computer perform. Imagine when you want to create a packaged good. Let's say when you start your production, the good will go through the conveyor belt. You go to station 1, station 2, station 3, and then you get your final product. Pretty much similar to computational photography. This is a snippet written in Python. It's very simple. So when you take a photo, for example, the machine will create a raw file, and then it will open the bitmaps, look at the pixel, and then it will quickly do the enhancement, apply like sharpening filter, brightness, etc. But due to the fast processor we have today, it performs this all step very quickly, so that you don't realize when you click and you get the image that it does all these things. But in real life, of course, this would be much more complicated. And just for your information, Python is a great resource for image processing. They have, I think, 10 plus robust library that I've known of to perform this sort of task. We're not going to talk about Python today. Next, I also want to introduce you to the AI-powered editing software. These days, there are many sort of like AI photo editing software. For example, on your phone, after you take photo and you click edit, the magic wand thing. That's what it does. It automatically adjusts like brightness, color, etc. But we're not going to look at that. Just an introduction to Deep Angel. I didn't create this. This was introduced, developed by MIT Media Lab. What it does is, it's the AI that erases objects from photograph. Sounds normal. But the thing is, this app actually detects an outline object that it already knows. So the app actually knows what it is. And then it removes the object, and it imagines what would the photo look like without those objects. Here, let's say I want to remove person from this example photo. So Deep Angel actually knows what persons look like. It removes automatically, and it recreates the scene without people, object in it. So this is sort of like the future of photo editing software that it will keep learning, and then it knows exactly what it needs to do. Perhaps a little more interactive photo editing software. Again, another software developed by MIT and IBM Watson. This is a joint research effort to tackle the AI in advanced imaging technology. Let me show you quickly. Can you see? Okay, it's a little small. Okay. So here, it looks like a small, a normal pen app, but it doesn't just pen. The program actually knows what are these objects and what it's supposed to do. For example, here I just want to draw a tree. It's a tree. So it knows that, oh, okay, I need to draw a tree. And then I was like, okay, I want to put some grass on this. So it's like, okay, just like whatever. Oh, not bad. And it's like, okay, I want more doors. So I'm just gonna paint door here. Yeah. So as I keep using, the program actually learns what I want to do, and it learns the object that I work with. You can make more domes here as well. Why not? I need more dome here. Well, I need one more. Fabulous. So this is pretty cool. I can keep doing this all day, which I'm not gonna do it. So this is just an example of what the future may look like for your editing software. You may not have to do all this yourself. Perhaps you can just code. Computer, please create my photo at night in front of Eiffel Tower. Boom, you got it. Then, that brings me to the question, what will the future look like? Well, in any industry, the benefit of AI is to make our life easier. It simplifies the process of taking and managing photos. In this case, I think we need to harmonize and learn how to use this tool to make our life easier and work in a more efficient way. It definitely helps us to make photo looks better. Imagine when you go to the mountain at night, you see a beautiful sky, you see a moon, you want to take that photo of beautiful moon. After you take it, disappointing. So the AI will actually bridge that gap. It will help to bridge between what your eyes can see and what the camera can capture. So you have more sort of better quality of light, better quality of colors, and so forth. And there is no argument that the AI will introduce the biggest breakthrough in the editing capacity. There will be more and more advanced software that can manipulate photo in a way that we cannot even imagine today. So, will there be any photographer left in the world? Absolutely yes. I think there will still be a room for an experienced, well-trained photographer who understand color, composition, emotion to create work with a touch of humanity, at least for the time being. So that concludes my presentation today. If you're interested, here are the links, or you can ask me later of resources that I use. And thank you very much for your time today. I hope you enjoyed it.
Once again, thank you, Khan, for his amazing presentation about photography with AI. If you want to learn a couple of new tricks about utilizing AI in photography, talk to Khan. And right now we'll take a break and we will resume at 2:30. Thank you very much. Another round of applause to Khan. welcome back again. Today we have animations with JavaScript presented to you by Ryuki Kuga, and he is one of our students who are taking our 12-week immersive course, and a round of applause to him.
Alright, good afternoon everyone. How's it going?
Good.
Nice, cool. So today, my name is Ryuki. I'd like to talk about animations with JavaScript. And before diving into the topic, I'd like to talk a bit about myself. I'm from Tokyo, Japan, and I like martial arts and anime. As for martial arts, I've been doing martial arts for more than 10 years. Started off from karate and moved to boxing and kickboxing. I still enjoy them. And also, I like anime. I would recommend Dorohedoro and Dami's game from this season. Who here watches anime? Who here likes anime? Good. Cool. Talk to me later. Alright. Which ties into my topic, animations. And these are awesome animation libraries in JavaScript that I'm going to cover. For 2D animations, I'm going to cover anime.js. For 3D, I will cover 3.js. But first, why use libraries? One reason is you can have a quick start. Without having knowledge in creating animation with plain JavaScript, with these libraries helps, you can have a quick start. Second, capability. Sometimes you just need libraries to make complex animations. Third, suitability. Most animations made with JavaScript are multi-step animations, and for this use, these libraries are suited. And what is animation? Do any of you guys come up with the definition of animation? Anyone wanna? All right, so I'm gonna define this word. Animation is a way of making a movie from still images, and these images I can call images in frames in animation. So these are interchangeable terms. So the frames are put together one after another at a fast speed to give you the illusion of movement. So if you see the animation, you don't recognize them as frames. We just see them and recognize it as animation. Purpose of animation, obviously, is an attention grabber. Of course, I'm convinced that you look at the right side not because of his face, because it's moving. It's an animation. That's what grabs attention. Second, animation is processed faster. Our brain can process animations 60,000 times faster than plain text. And also, animation makes your website unique. By having non-static context in your website, makes your website just stand out. Because most websites have only static context. So if you want to make your website unique, this is for you. And I'd like to introduce Anime.js. Anime.js is a JavaScript animation library, and it provides us a smooth and elastic animation. And also it simplifies the code base, which I'm going to prove in the next chapter. So this is the animation created with both JavaScript, vanilla JavaScript and Anime.js JavaScript. In this code base of vanilla JavaScript, first you need to select all the elements you want to animate. And since more than one element, you need to iterate through them. And set the timer to make a delay on each element. But if you look at the code, there's some tricky ones. First, there's a promise. Promise is something that might return value. So it's an asynchronous value. And also we have set timeouts, which you need to provide another function inside. And also you have to provide an amount of time you want to use for delaying. But if you look at the anime.js version, it looks much simpler at the first glance. First, you just need this method, timeline, to which we can add animations to. Second, in each section of animation, you need to target the element. And in this section, you can target CSS properties as well as any DOM elements, and also JavaScript objects too. So I'd like to show you this on the animate.js website. So if you target the battery, in this case, this object, I'm just gonna, yeah. And you can animate the normal JavaScript object too, which is pretty cool. Secondly, you can make use of a nature method to describe a delay. If you compare these, the amount of code base you need in vanilla and anime.js are not really different. But if you take a look at each step, you can see how nested it is in vanilla and how clean it is in anime. So you can see the complexity of the code base of vanilla version and how simple it is when you write it in anime.js. And I'd like to show you a quick demo. This is the animation I created. So basically, it's a loop, so it's going back and forth. And if you see the code base of this, it's really simple. Just a few lines of code, and you can make this animation. And I'd like you to take a look at this background color section. You can actually specify a function in order to describe a property, even background color too. For delay too, you can make use of index to iterate through and make a delay. And making use of index, you can change the color with different R and G and B, so red, blue, green, blue elements. Cool. So want to code up your animation with JavaScript? Cool. So, okay. Alright. So I'd like to share some insight and tidbits I gained throughout this learning experience. First, 2D animation. In 2D animation, you can make use of your existing coding skills. It's really methodical. I said somewhat methodical, but it can be really methodical. So you can make use of your coding skills, make your animations really logically. So if you're already a developer or if you like to code, you can make use of that skill when creating animations. And 2D animation has already quite a big market, larger job prospects, bigger community. It's always good to have. And then I'd like to talk about 3D animation. For 3D animation, I learned about 3.js. 3.js is a JavaScript 3D animation library, which is really interactive. Although it's debatable that whether 2D animation or 3D animation, like which is better or which is more appealing, but there's no denying that 3D animation can bring you more realistic experience, just because you see everything in real life as 3D. Think of a piece of paper. It can be used to describe 2D element, 2D dimension. But if you think about it, how thin it is, it's got a height. So everything you see, almost everything you see, can be described as a 3D object. And also it's one of the most starred JavaScript libraries on GitHub. It's as popular as React and Node, surprisingly. And I'd like to show the demo. And this is the 3D world you have. And this can be made really easily. I'm going to talk about the code base later, but I'd like to take I want you to pay attention to the surface of the sphere. Basically, on this surface is a reflection of the panorama view around this sphere. So basically, it's just reflecting all the things around it in this 3D world. You can look at the sky and also the ground. And this is a code base for it. You don't have to look into it. That's not the point. That's not the point. The point is, it's only 45 lines of JavaScript code to make the 3D world as well as the sphere hovering in the air, reflecting all the views around it. First, you need 3 steps. you can think of this process as, yeah, again, a way of making a movie. First, you need something to shoot. So you need a camera, and you need somewhere to shoot it. And lastly, you need that movie to put it on the screen. So these three elements are fundamentals of 3D world. So you just need camera, scene, and renderer. And you can think of this process as making a movie, as I mentioned. And in order to make a 3D world, so this 3D world is actually comprised of 6 photos called skybox photos. And it just needs 6 photos like these and load them. And adding it as background to the scene, you can have this 3D world. This is an example of skybox photos. And secondly, you need to display the sphere. In order to make an object in 3D.js, you need 2 things. One is material. Material is basically an appearance of the object. And what I was applying to the surface of the object is a map, and using a map. And what I mean by sphere camera.render target is it's basically reflecting all the views on the screen. So if you specify map as sphere camera render target, it's going to render all the panorama view to the object. And secondly, you need geometry. Geometry is a shape of the object. And then putting both of these into 3D.mesh, that creates the object. And setting the position that the object is going to be rendered. And then adding it to the scene, and that's gonna, and then the object is gonna appear in the 3D world. And next, you need the camera to look from. This is throughout the angle. So you need to instantiate the camera, set the position as I did with the object, and then add it to the scene. And that's all you need to create this world with the sphere hovering in the air. Cool. So, do you guys want to make 3D animations with JavaScript now?
Sure.
Oh, nice to hear. So, as with 2D animation, I'd like to share some insight. For making 3D animations, you don't really need academic knowledge. You can get started, and you can even make complex animations without any technical expertise. And as for limitless possibility and growing market, 3D animation uses these various industries are using 3D animations, such as interior design architecture. Just by providing the clients the model of what they're going to get is quite helpful. For medical and healthcare fields, nowadays we look up our conditions, or we do searching for our medical conditions online first, because of the rise of the internet, as I mentioned. And more medical professors are realizing how powerful 3D animation can be in the education and market and customer interactions, especially patient communication. And these organizations or institutions can help patients to have better visions of what they're going to go through, the medicines they may need to take, the operations that they might have to go through. And I'd like to go explore a bit about 3D animations from this 3D.js. For example, this is made with 3D.js with a framework called physics.js. You can just play with like this, Jenga, really powerful. And this is actually written with only 100 lines of code. This is not much considering how realistic it is when considering the physics. And you can just distract it by just pulling out the bottom. Oh, great. Oh, just like this. And you can just make it disappear into the darkness infinitely. I really enjoy this process. Yeah, it's really, I don't know, I just like this distracting things. And also, I like to talk about the use of 3D animation in the car industry. So this company is using a 3D model to describe their car. So you can look at the 3D model from every angle, and you can hop in the car. And from inside the car, you can see the view of inside the car. Every angle is available. Like so. So, thank you for listening. My GitHub handle and the LinkedIn handles are right here. And also, QR code is available on the screen. And thank you for listening.
I think I'm inspired to add some 3D animation on my personal website now. So, yeah, thank you very much for the amazing talk. And if you are as fascinated as I am, feel free to talk to Ricky. He has a lot of insights about creating 3D and 2D animations. Meanwhile, we shall take a break and resume at 3 p.m. Thank you very much. p.m. So for those who are just arrived, this is our 7th big MiniConf. All our presenters today are the students who are taking our 12-week immersive course. We just ended week 8 and they are presenting their research and their tech topic today. Okay, so next one we have Max Stewart talking about CSS art and creative CSS. Welcome.
Good afternoon, everybody. Hope you're all feeling creative this afternoon. Anyone here an artist by chance? Raise your hands. Oh, that's hello. And also because artists usually don't like calling themselves artists, does anyone here make art? I got more. Okay, that's wonderful. Welcome. So let's get talking. Today we're going to talk about CSS art, and anyone who has made digital art before, this might be slightly familiar to you, but with a new strategy on how to do it. So let's see. I love when this happens, guys. Okay, well, my name is Max, as you heard. This is me. I am a software engineer. I am also an artist. I usually work in traditional media, and my art is usually made out of lines. Usually none of the lines are very straight. And when I work in digital, I try as hard as I can to reproduce traditional styles. So I've done that in CSS, hopefully. You'll see that in a second. I also have been really interested in front-end development lately. So I think CSS art is going to merge those two pretty well. Let's find out. So if you're wondering, here's kind of what CSS art is. It's a picture made out of pure CSS. That means you get two options. You have HTML page and you have a style sheet. That's all. It's also kind of invisible, as I like to say. If you try to interact with it on your HTML page, you'll get nothing. This is what happened when I tried to, I know what happened, but I tried to save my completed piece of CSS art. It shows as a web page. So there's nothing there technically. That's pretty cool. And also made out of HTML elements. If you want to make an interesting shape that you can't make with a single div element, you have to kind of fake it. Here is 4 out of maybe 50 circles that make up a single cloud. So it's fun. Okay, I didn't do this. Immediately, I'm gonna share that. This is a really famous piece of CSS art. Her name is Francine, and she's lovely, and she was made by a developer called Diana Smith. As you can see, Francine looks like an oil painting, a little bit. And Diana Smith has used some, what I think are pretty great oil painting techniques to make this. One thing, if you notice, there are no lines here. In reality, there are no lines. There's no line really separating this shirt from my arm, obviously, so you kind of have to fake it. She does that by using shadows next to highlights to give a perception of difference, even within the same color. Everything here is blue, but here is a shadow and here is a highlight, and that's how you can tell that there is a fold in her dress. So that's pretty complex to do in CSS, and I was wondering, why did she choose to do that? Why are there no lines? No borders. Let's get talking about that. So not just Diana Smith, a lot of people have been making interesting CSS art. If you want to check some out, here it is, cssart.com. It's kind of like a place where people post things that they made. This was my first introduction to CSS art, actually, looking through here. As you can see, lots of different styles, lots of different skill levels. There is a photorealistic mobile phone right here, which I don't know if you want to start thinking about how they did that. But there it is. So I'm going to make my very own piece of CSS art. If I'm starting this out for the first time, here's kind of what my thought process was like. First, I need a reference image. You start a new media for the first time, it's good to either reproduce something or use something that you can see. And since there's nothing like that, I'm going to use a reference image. I chose something called the Wheel of Fortune, which is a tarot card. It has significance. It means chance and surprise and not knowing how things are going to turn out. Thought that was pretty good for a new strategy. So I did some research to try to start making the Wheel of Fortune. I found this article. If you want to get started with CSS art, I recommend it. It's very good. It helps you make a little ice cream cone with a smiley face. And I was so proud of myself when I did this. I had never done CSS art before, so there it is. I was immediately ready to start something more difficult. Here's my ice cream cone. You can make this too. Notice one thing about this ice cream cone though, and that is no borders. There are no outlines here, no lines. As a line enthusiast, I was starting to get a little bit worried. Why are there no lines? Well, here is my completed project. So this is what I ended up making. This is my representation of the Wheel of Fortune. I chose cats, because I like cats a lot, but usually it's a lot of different animals here. I have borders here. This I had to fake, basically. A lot of different circles here using the border top, border right, border left sort of thing, overlaid with new div layers that are the same color so you can't tell that the border goes all the way around. A lot of fiddling with it, testing, trial and error, and things like that. But absolutely worth it. This was a lot of fun. So my technique, I'm going to show it off. Here is the symbols along the outside of the Wheel of Fortune. It's a bit simple, so I thought this would be good to see. Every single symbol, let's start with this one, is wrapped inside of a div element. And inside of that are all the different shapes that make up that character. I can't just make 1, 2, 3 strokes done. You have to pretend that you can do that. Here's how it works. So we start by creating that container, that outer element. And this is a really good strategy, but I didn't know that until after I did it, but here's why I chose to do that. In traditional media, in oil painting and whatnot, you start with a bottom layer that isn't going to be visible in your finished product. It should be 2 colors usually, one that represents a shadow and one that represents a highlight. I like purple and yellow. So I was not going to use this really tacky bright pink color, so I chose that to be my base. And knowing that it's not going to be shown at the end, it ended up helping me a lot. So the first detail here goes inside. The base of the T is, it's not really a T, but this is the most obvious shape, so I did that one first. And from there, you arrange the details. When I made the next shape, it went here. I had to use margin and position them, so that's total 1, 2, 3, 4 details making up the shape of the T. Now I can hide my base layer that I don't need anymore, so just take away background color and there it is in position. Okay, so what I learned from doing this? A lot. And it was really challenging to me at first because I didn't know strategy. I couldn't really use HTML so well in my front-end development yet. But after going through this, I noticed that I can get a lot more creative with the CSS styles that I use now in the apps that I'm developing. So this wonderful quote is from an article that I looked up in my initial research. Also, if you want to try making CSS art, pretty good article. Time to break it. A good part about CSS art is actually that it only works in certain Chrome browsers, and that's all. And when you look at Francine, that beautiful oil painting I showed at the beginning, the developer had a warning. It said, this probably won't look that great outside of Chrome, so anything else it's gonna just break. And everyone who read that said, oh really? And immediately proceeded to break Francine. So let's look at some examples of Francine. In Internet Explorer 7, I love her. Alright, and here she is in Chrome 9. Pretty good, she has some shapes now, she's getting there. And here she is in Internet Explorer 5. This one is by far my favorite. So I was waiting to finish my Wheel of Fortune, my experiment, so I could do this to my own art, because, wow, this is a dream, isn't it? So here is the Wheel of Fortune, completely broken. Internet Explorer 7. I love it. Squares. Apparently, border radius. Not really a thing yet in this operating system. Safari 10 did an okay job. Only thing I noticed is, yeah, the positioning is horrible and a mess. The borders are still here. My border top strategy breaks in Safari, so now I know that. Borders just show up all the way around anyway. Firefox 7, I don't know what they're doing. I've made some sort of cat moon god. Thank you. I don't know. But basically, I spent weeks choosing little tiny numbers and editing, and positioning everything just so. And then I put it into this browser, and it does this. And I think that's beautiful. There's a quote from Picasso that I must talk about right now, which is, I spent 4 years trying to learn to paint like Raphael, and a lifetime learning to paint like a child. Artists need to learn how to break their composition, how to make things look like it's unintentional. This is pure art here. This computer is the child, has created art kind of better than I could possibly imagine. Just my opinion. Anyway, moving on. I also did another little experiment, which is making pixel art in CSS. I had not known that that was a thing until I started my research, so of course I had to do it. The strategy is entirely different. Not a lot of positioning goes on. You just make a grid of pixels and use this nth child strategy to the number of pixels. You color it in, simple background, one line here, and then you animate it. We'll go over that code in a little bit. This is what I ended up doing. This is every phase of the moon in purple. So every single one of these is a different style sheet, and because you have to go line, nth child, it's probably like thousands of lines of code, but fun and worth it. Here's how I did it. I started with a grid of pixels. As you can tell, I didn't end up using that color again. That strategy worked really well for me. Pick a color you will never see again. It's so helpful. Set the pixel background, whatever. Put my number in, and I moved on with my life. And drew the outline by number. It's very easy to just start with a circle. Next thing I did is I filled in the flat color. This is not necessary for making pixel art in CSS, but this is how a lot of traditional media works. Printmaking and painting in ink and whatnot. Visualize the layer of color that you need. After this, I went on and I did the lightest shadow, everything, then the darkest shadow, everything. And then when the shadows were done, the last thing I did was the highlights. So here are all the layer colors. That's a lot of different layers of color. I probably reassigned the pixel color several times. Coding practice, debatable. Artistic practice, wonderful, please do it. And at the end, remove the grid and the background, and here it is, the moon. Into that a little bit more, I decided to animate it. Here is a GIF version of my animation. It is usually 100% smooth, try that. So animating was just a blast because, like I said, I wrote thousands of lines of code of individual pixels, and all I had to do was very little. First, make a sprite sheet. This is a PNG image of all of my generated moons right next to each other in a line. So I'm going to, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, say I want this to divide into 8 little sections here. That is all it is. This is just one development. This is it. Animation. I'm done. And so yeah, so 310 by 310 done 8 times using this image. It's going to animate for me. I use keyframe to set the position to the negative width of the entire object, and that is all. And then it just goes. It's really easy, and if you're interested in animating with pixel art, I recommend it. Anyway, so what did I learn from this experience? First, better understanding of HTML, trying to apply that do your base layer first and then paint over it traditional media technique really helped me understand the concept of a container a lot better. It's very clear. More creativity in front-end design. You can get a little bit weird with the things that you want to make, and it's great. In one of my projects, in the middle of doing this, I put like a crescent moon on the side of one of my developments, just because I could. And patience. Maybe you can tell, this takes a very long time to do, but Thank you for nodding. But it's really rewarding to see what comes out in the end. Hard way to do something easy. Here I am talking about that vector art, the first example that I did. I could have drawn that in like an hour, maybe. I don't do vectors that much, but I could have rendered that maybe in a day. It took me weeks to do this, so just a different strategy, I guess. But easier way to do something difficult. I find creating pixel art to be really hard. So in the context of pixels, knowing what number on the grid your pixel is going into every single time makes it really clear what you're working with. I would recommend this, again, if you want to improve your CSS skills, if you're kind of confused about how do you even make CSS art, try it out. You will learn a lot right away. Okay, well, thank you everyone for listening. This is my lovely moon phases repository, and this is the Wheel of Fortune. So if you want to go examine that, look at just how many lines of code it is and whatnot, try to break it. Please try to break it. Go ahead. And yeah, my contact information is over here if you want to talk about CSS art some more. But thank you, everybody.
Thank you, Max. I consider myself not an artist. I know nothing about art, and I've been seeing her presentation from the first iteration to this final product, and every time I see her presentation, I am still being blown away by the effort she put into the art, and I highly recommend you talk to her, talk to our CSS diva, how to create CSS art. Okay, and meanwhile, we will take a break and we shall resume at 3:30. Thank you very much, and another round of applause. Today, I keep saying tonight, but sorry, this afternoon, and it's 3:30. We have Daniel Rini introducing, giving us a brief introduction to image recognition.
Hey, hi everyone. So I'm going to do a talk on a brief introduction to image recognition. Before we get started, I'd like to tell you a little bit about myself. So my name's Dan, I'm from the UK, and I'm really into rock climbing and cycling outside of doing this. Previous jobs I've had, I've been a nurse for a few years and a train driver. Now I'm a software engineer, so I'm enjoying it so far. So I'd like to talk about image recognition. What is an image? We see images all the time, they're everywhere. We see them on our phones, print media. An image digitally is a visualization of a real-life object in a 2D form, a collection of pixels that represent different colors. So a computer sees an image very differently to how we do. If this was fed into a computer, it would be a series of numbers. So we'd see 0 to 256, for instance, for a type of image. If it had more color spaces, it would be more numbers. Image recognition involves actually analyzing the pixels and the patterns within an image. And when we recognize an image, we can then identify core features as a particular object. So why is it important? Why am I talking about this? There are a huge amount of applications. It's quite a happening field at the moment. One of them is robotics. Increasingly we're seeing robots which are able to identify different parts in warehouses and to use 3D vision and machine learning techniques to identify different parts and to pick them up, making warehouses more efficient. Another sector where this is going to be applied quite a lot is in healthcare, analysing test results, x-rays, feeding the images in and being able to identify problem areas that people may miss. So when you feed it into a computer, it tends to be a lot more accurate now than if it's just people. Autonomous vehicles also very popular and growing at the moment. Image recognition is used for navigation and to sort of localize and identify different hazards. So when you're going down the road, your car is looking around using a camera to identify different things, using image recognition to identify hazards. So I'm going to go to the start, when this field started to be explored in more depth. This was 1959. There was a famous study done by Hubel and Weisel called receptive fields of single neurons in the cat's striate cortex. So big name, but basically what they wanted to do is analyze how a cat, they use other animals as well, how a cat could see things. So they spent a few years anaesthetizing these poor animals, putting a stimulus in front of them and then wiring electrodes up to their brains, and then showing them different visual stimuli in the hope that they could get a response from them. One day they were removing one of the slides, which created a very sharp shadow across the screen, and they managed to get an electrical signal back. Over time they did more studies on this, and they worked out that different areas of the brain would fire for different patterns, different images that the animal was recognizing. And this was applied to, they thought maybe we can teach computers to see like this. So I'm going to show a timeline now. In 1959 we had the first digitally scanned image. We can see on the left, this is an image of one of the researchers' children at 3 months old, so I was quite surprised at how high quality this image was in 1959. Image recognition then became more based on using geometric primitives, so different types of shapes and corners and angles. And then in 1989 they had been doing a lot of more research to apply machine learning techniques, and the first convolutional neural net was used in 1989 to recognise handwritten zip codes. I was quite surprised that that was so long ago. It's quite amazing. In 2001, facial recognition became much better, and we're starting to see that everywhere at the moment. And then in 2010, we started to see a lot more deep learning and convolutional neural network applications to identify things within images. And in 2012, there was a massive breakthrough with AlexNet, which is quite a famous convolutional neural network. It managed to increase its accuracy by 9% over the year before. And after that, a lot of research, a lot of money was poured into using these convolutional neural networks to identify images. So to actually see something in an image, we need to use feature detection. So techniques that rely on detecting actual features within an image. We can see over here we've got sides, we've got edges, we've got shadows, we've got gradients. They're all key areas that we can look at to identify something. And computers can be taught how to do that. I'm going to show a very simple example. This is a Python script using OpenCV, which is a framework that you can use for Python. You can load an image in, which we do in line 3, and run it through something called a Hoff gradient, which this one is looking for circles within an image. So after running that, this is my output. So the computer managed to draw circles around all the circles it found and identify those in an image. So this was really fast and worked really well, but it would be really tricky to apply this for all different shapes. It's very specific, has a very specific use case. So this isn't a reliable way to detect for complex geometrical objects. So how do we see? Because I think it's important to cover this because neural networks and convolutional neural network are based upon how humans see. So when we look at something, we perceive the colour, the depth, and the sort of the form of an object. Our brain then groups all of these together and kind of forms a structure which we then apply descriptive labels to. So if I looked at a chair, I might see different features of it. I might see the chair legs, I might see the back of it, and then eventually kind of put that all together and I know it's a chair. And we do this all the time without even thinking about it. But for a computer to do, it's quite tricky. The researchers looked at this and they thought, well, we can build something to simulate how the human brain connects bits of images in this way. Neural networks aim to do this. So they take inputs, they apply some complicated linear equations, and they aim to get outputs out. So we can feed information into one, it goes through the layer, and we want to get predictions out of it. I'm going to explain this in more depth with a convolutional neural network, which are the kind of the state of the art at the moment for image recognition. So firstly, we need to feed an image into the system. In this example, we've got the number 6, which I took from the famous data set, and if we zoom in, we can see that each pixel has a different value. So there's a cluster here. The higher the value, where they're clustered together, that tends to indicate a feature or something specific about the image that we need to look at. This is maybe an easier example to look at. So here we have a picture of a dog, a bike, and then there's a car in the background. Each of the main features of the image are grouped with the different colours. So once an image has been fed into the system like this, it goes through a convolution layer, which through a convolution layer which aims to map specific features of an image. So imagine this is our image. We've then got a 3x3 square that would move along each pixel, and it would add the value of all the pixels together, apply some mathematical equation to it, and aim to get a result out. So we kind of downsample and get a variety of different numbers representing the edge or the feature that we're trying to see. And this happens for every single possible combination within that image. So we end up with a lot of layers. It then gets fed to something called a pooling layer, which takes the highest value from a small sector of the map and keeps it, so it gets kind of downsampled again. So we end up with very many layers, which we can see on the left, with a number that represents the feature that they're trying to look at. We can have many, many, many of these layers feeding into each other. The ultimate aim is to get a different probability for different sets of features, so that eventually the model can tell you what it's looking at. Once that's all done, it goes to a fully connected layer where all the values are stacked and each value will connect to the answer that we want. And all of these values have weights. So one of these nodes might represent, if we're looking at a picture of a dog, the leg of a dog, we might have higher numbers for that specific part than down here. And then we can apply sort of confidence interval to see what we're looking at, so it can tell us. So as I said, we can have many of these layers, and combining them can really increase the accuracy of the network that we're using. So this is an easier way to look at it. We have our convolution layer that we talked about earlier, our pooling layer, another convolution, another pooling, keeps going on, and eventually you end up with our fully connected layers. So we can get predictions at the end. So in order to do this, we actually need to be able to train it. So we need to be able to teach the network about what it's seeing. We can feed it images and it will work out what it's looking at, but we need to be able to actually tell it if it's looking at the right things. So during training with one of these, we would feed it an image with labels, and then you can test how accurate it is. In practice, this isn't done a huge amount. People tend to use networks that have already been made. So they do this using transfer learning, which is where you can use the pre-trained models. There's a massive advantage here because making a model, you need a huge amount of data. Your data sets need to be really big in order to make it accurate. By using pre-trained models, you give your system a better ability to be able to generalize about what it's looking at, and it can take less time to get much better results. So this is an example I explored when doing this project. I used a Jupyter notebook running Python, and I loaded a pre-trained convolutional neural net called ResNet34, which is quite famous and is quite good. That has 34 different layers. The aim of this was to sort out different cat and dog breeds. So I used a open data set. I think it's published by Oxford University. It had a variety of all these different dog breeds, many pictures of them. The aim is to just separate out and see which ones we can see. So during training, it took me quite a long time to do this on my laptop. Each run through though, I was getting a smaller and smaller error rate, meaning that it was working quite well, and the learning rate was getting quicker as well. Ended up with a confusion matrix, which is a big grid of all the different breeds going down here, and then you'd have them along there. And if the breeds line up with each other and have a high number, you've got quite a good, quite a high amount of accuracy. The network that I put together had a lot of trouble distinguishing between these two dogs, which I think are going to look quite similar. So I can't remember which is the Staffordshire Bull Terrier, which is the American Pit Bull, nor could my network really. It did okay. But yeah, because they're quite similar images and they look quite similar, it would need more specific training in order to distinguish between these two breeds. So when we are talking about that, we have a bit of a danger, because if we get too specific with the images we feed a convolutional neural net, the data can be overfitted. It can be too specific to the image it's looking at. So we want it to be able to generalize and make assumptions not fit perfectly to the images it's trained with. So say we went back to this and we only fed it these two images for these two dog breeds. If we then ran the network, it would probably only identify these two breeds if it was fed that exact image. We want it to be able to generalize and make assumptions. I'm now going to show a different example using Google Vision API. This is a lot less dense than what I've just been through, and it's a nice way to be able to incorporate image recognition techniques into applications that you might be making. So an API is a way to access a company's systems. In this example, Google allow you to send an image to their endpoint, and it will run it through their convolutional neural network and then give you back a lot of different data based upon what they told you. In this example, I used a picture of a lion and a picture of a hippo. When you clicked on them, it would make a call to Google's API and give you its predictions back. So for the lion, it was very confident that this was a lion. And the same for the hippo, and it even told me it was a baby hippo, which is nice. You can get a huge amount more data from this. There are over 20 different categories that they can send back. Very easy to use. And I have got an example on my GitHub, which I can show you at the end if you'd like to explore this. It's very easy to get set up with. So there are some challenges with image recognition. As previously mentioned, the size of the data sets needed to train something and to use can be significant, and it can take a long time to group the relevant data together. Also, we need a lot of processing power to apply this. So graphics processing units are usually used over CPUs. They have a lot more power with this type of thing. There are also a lot of privacy implications. If you've got a lot of cameras going around identifying things, it's tricky. I think it's going to be more and more common that people understandably are worried about that. It's also quite complex. Using a pre-trained model isn't too bad, but if you want to get more involved in it, it can get very complex very quickly. Another challenge, which we also mentioned, the overfitting of data. You've got to make your network specific enough, but not too specific. So that can be a challenge. So what does the future look like? At the moment, there are a lot of companies putting a huge amount of energy into research, and universities as well. I think it's because image recognition can be applied to so many different fields and change them very quickly. All of these companies are putting a lot of money into it. Fujitsu, for example, are using image recognition for identifying parts. Google, a lot of money. Toshiba also putting a lot of money into developing automated car systems using chips. So if you're interested in this topic, there are a lot of ways to get started. OpenCV, which is the library I mentioned at the beginning, is really good, and there are a lot of tutorials online for using that. Jupyter Notebooks, which are applications online that you can store Python code in. There are a lot of examples, and I have linked to one in my GitHub repository as well, if you'd like to have a look. They're usually very well annotated, which means that you can kind of learn a bit about the subject. If you don't want to get too involved, using APIs within your apps is a really nice way to get some really good data back. Lastly, YouTube tutorials. I used quite a few of those. There are some very passionate people about the subject, and it's a really good way to learn more, I think. So, key takeaways. I hope that I have been able to teach you something and maybe get you interested in the subject. So, image recognition has changed a lot since the field started, and we are now seeing a lot of machine learning based approaches and convolutional neural nets within image recognition. And there are many, many opportunities. So I think it's going to be really interesting in the next sort of 5 years to see what happens with it. Okay, thank you very much for listening.
Thank you. I'm really tempted to build something to recognize salesperson or the one who deliver my Amazon package at my doorstep, so that I can just mute my doorbell if a salesperson tries to ring my bell using image recognition, thanks to very good introduction. And so now we're gonna take a 10-minute break, and we shall resume at 4 p.m. Thank you very much. 4 p.m. So the next we have getting into VR world using A-frame, and Miki Matsumoto will bring us into her VR world using A-frame. So let us give her a round of applause.
So, hello everyone. Thank you all for coming today. Today I'm excited to talk to you about getting into real world using A-frame. So, before starting, let me talk about myself. So I'm from I'm from Nagoya and I learned computer science in university. And I worked for IT company for over 5 years as a system engineer. And I used Java and I worked mainly on backend. But I wanted to learn front end as well. That's why I came here and to become a full stack engineer. And personally, I like to work out and like to go to the gym and I love Subway. So this picture of me when I stayed in California and I went to Subway as usual. Yeah. So today I'm gonna cover these topics. I will talk about introduction to VR and the difference between web VR and native VR. And also I'll mention frameworks and library to create web VR application. And I'm going to show you how to create a web VR application with A-frame. And I'm going to wrap it up with the future of web VR. So to begin, let's talk about introduction to VR. So VR stands for virtual reality, and it's 3D and computer-generated environment. It can be explored by human, and the user can become part of virtual world. And VR has ability to track users' motion, like eye moving or head moving. And I think it sounds fun for me, and that's why I choose this topic as my tech talk. So VR is commonly used entertainment, as you know, like games or watching movies or watching sports from remote place. And also VR is commonly used education and training because VR is effective and useful way to represent a special situation like military training or medical operation and so on. Other than that, there are many ideas and there are many ways to use VR. So let's move on to the difference between web VR and native VR. So web VR application is just web application using web VR API, and it runs on browser. But not all browsers support web VR API. On the other hand, native VR is designed for particular device, and it needs special hardware such as virtual headsets. And native VR application is available through a device's application store like Google Play or Apple Store. So the difference between web VR and native VR is that native VR is high interactivity and high graphics quality. But web VR is available for much more users because web VR is VR headset is not necessary to watch web VR application. So the advantage of web VR is it's easy to start and easy to release because web VR application is just it's almost same as web application. And it's easy to share. if I want to share my WebVR application with others, you can just send a link to others. So I'll talk a little bit about frameworks or library to create WebVR applications. And so Unity and 3JS is a powerful and famous framework and platform, and many developers use this platform. And React 360 is also famous, and for many developers who are familiar with React, it's easy to start. And how about A-Frame? In my opinion, A-Frame is the most easiest way to create WebVR application. Because if you want to create a simple WebVR application, you can create it with only plain HTML. So that's why I choose A-Frame library as my first step to create real world. Actually, A-Frame is based on 3JS, but you can use both of them, and you can use other library in combination. So let's move on to the how to create WebVR application with A-Frame. So all we have to do is creating new HTML file and import A-Frame library and writing plain HTML tag. That's it. So it sounds easy for me and easy for everyone, I guess. So today's goal, we have one goal, is that by the end of this talk, you start thinking that creating VR is easy for me, and we don't need to be a great talent developer. So I will show you my demo at first, and this is we're gonna create today. So today we're gonna create this WebVR application. So I will show you quickly and easy way for everyone to try it out. But before I do that, let me make sure current browser compatibility. As you can see, not all browsers don't support WebVR API. So if we want to create WebVR application, we should consider which browser we should use. And please be careful the latest current compatibility when you start project. So today I will take you through these steps, and I want to show you some code and demo that I created, so that you can see what you can do with each step, and you can see how simple it is. So let's get started. First of all, I wanna start with import A-Frame library. So I created new empty HTML file at first, and include A-Frame library. So if we go to the official documentation and go to the get started, you can see the library file that we should include. So let's see what happens. Oh, sorry. There's not anything, because we didn't create anything at all. But if if you open the console, you can make sure the FM library imported, and you can see the version of FM. So next step is create trees. All A-frame components happen within async tag. So inside it, you can add new components. So I'm gonna create new async components. And before creating components, let me talk about many kinds of objects we can use, which is called primitives. So we can use some kinds of primitives in combination. And if you go to the official document, you can see the implementation of primitives. And you can see some attributes and value you can use, such as height or colors and so on. For example, position attributes take three-dimensional x and y and z, so that you can place an entity at a certain spot in 3D world. So let's try to create objects. So let's say to create trees, I come up with constructor. So we have 3 cones and 1 cylinder. So we have 1 green cone, and I'm gonna add 2 more cones and add 1 cylinder here. Also, after this step, we add more object and trees. So the code gonna be messy. So I'm gonna put new entity and its name it class name as small trees. So let's see what happens. So we have 1 tree, but this tree feels isolated. So I'm gonna add more trees. So let's see what now. So now we have some trees, but as you can see, every time I reload it, we have to look for trees. So it's a little annoying. So the next step is setting up a camera. So I'm gonna create new camera entity and set position. So now when every time I reload it, we don't need to change perspective. So the next step is setting environment. So I'm gonna add interesting environment in this world. So I'm gonna use this library. And first of all, we're gonna include this library and add a new component to represent forest environment. So now, we have interesting environment, but all trees are buried by snow. So, oops. Oh. Sorry, just a moment. Alright. Sorry for that. Now, trees are buried, still buried. so I'm gonna add new entity and change all trees position. So now, yes, tree appears. And let's move on to the next step. Oh, sorry. Next step is to create signboard. And it's similar to trees. So I come up with this structure. We have one box and one cylinder. And I added new components as usual. Also, I added new text component, and I wrote a typical and familiar message for programmer on signboard. So now we have signboard and finally hello world. All right. The next step is my favorite part. Let it snow. So I'm gonna use this library, and as usual, I'm gonna include this library and add new entity to represent a snow scene. So now we have a snow amazing scene. Yes. Thank you. So so far we wrote HTML tag directory, but we can use DI too. So I'm gonna explain it. It's a A-frame inspector, which is virtual tool for inspecting scene. If you use A-frame library, you don't need to install anything. You don't need to set up anything. So with this inspector, we can drag and rotate and scale entity, and you can tweak component and property. Also, we can see the results immediately. You don't need to go back and forth from between code and browser. And this is a shortcut to run to this tool. And official document doesn't mention which browser are supported, but as far as I tried, it's now on these browsers. So I'm gonna try it by using demo. So I will type the shortcut. Oops. So on the right side, we can see the entities. And if I click the entities, we can move the component directly. So it's easy way to make modify real world. And now we have a simple web application. So we're gonna try to make your application to public by GitHub. So if you have a GitHub account, there's an easy way to make it public. So I have a repository for this demo, and go to setting and scroll the bottom. To make to make our VR application to public, we have to take 2 steps. One of them is make this repository public, and also we have to choose publishing branch from your branch. So now anyone can see my VR application with this HTML with this URL. Alright, let's check them out later. And so far we created a simple web VR application, but there are many ways to create VR application. So please check them out to create your own VR application. So to wrap it up, I want to talk about the future of VR a little bit. Actually, a new standard is coming along in web. It's WebXR. It's not only for VR but also AR. And WebXR is replaced to WebXR. But it's still developing, and it's not recommended to use it in actual project now. So please keep it up with the latest current official documentation. So lastly, I'm gonna show you my advanced demo using animation. This is a kind of island in the sky, and I use JavaScript and anime.js to move object. And I have one gimmick on this signboard. Yeah, that's all for my technical. Please take them out.
Thank you for your amazing presentation over here. Never have I thought about, I always think creating a VR is like a rocket science to me, and never have I thought about I can just create VR using HTML and pure CSS and JavaScript. And thank you very much for your wonderful presentation. And we shall take a break now, and we will resume at 4:30. Okay? 4:30. Without further ado, we have Sarah Ting presenting Unity from scratch to multiplayer. Welcome.
Yeah, thank you. Alright, good afternoon everyone. I hope everyone's been enjoying MiniConf. Thank you for coming to my talk. So let's start off with some self-introductions. My name is Sarah, and this isn't working. Okay, here we go. I'm a Australian web developer. Unfortunately, my favorite language is PHP, and I love pastries. Sorry. I came to Coca-Cola because I wanted to learn some new things. I wanted to expand my skill set. So that brings me to my topic for today. I'm going to be talking about game development with Unity. So the reason I chose this topic is because I've never worked with Unity before, I've never worked with C# before, and I wanted a challenge. And I was disappointed because it wasn't challenging, it was really easy. So today, I'm not going to be talking too much about code. I just want to show everyone the general workflow for getting started with Unity and hopefully inspire some of you to get started with your own games. So what I'm going to be talking about today, firstly, why Unity? Secondly, how to create a basic game. And thirdly, the bells and whistles. We're going to go into making a main menu and multiplayer mode. So let's start off with why Unity. How many people in this room today have worked with Unity in the past or know how to use it? Yeah, quite a few. How many people have heard of Unity? Yeah, basically everyone, right? So the simple reason for why Unity is because it's big. As of last year, it accounts for 45% of the gaming market. And if you look at mobile gaming only, it goes up to 50%. So that means a lot of stability, a lot of opportunities, lots of resources, lots of documentation, lots of community support. Chances are one of your favorite games is probably being made with Unity. Looking at this is what made me got interested in designing games. And it also has excellent support for deploying to multiple platforms, so you can just make your game once, deploy it anywhere, has great market reach. And also the asset store, which I'm in love with. If any of you listen to Ashley's talk at the front, you probably already heard about this. This is just a place where people upload assets that you can use in video games. So stuff like 3D models, 2D artwork, audio, music, scripts, packages, anything you can possibly think of that you might need to make a game, you can probably find here. So a lot of it is paid because people need to pay bills, but a lot of it is also free. So if you just want to prototype a game, whip something out quickly, it's a really great way to get started fast. And also it's just fun to go through everything and get inspiration for what you want to make next. Alright, so that's enough about why Unity is great. Let's get started with making our first game. So what I want to make today is a very simple game based off one of my favorite games when I was a kid. Some of you may know this, it's called Katamari Damacy. How many people here have played this or know the gameplay? Alright, so you guys are going to know what I'm talking about, but for anyone who doesn't, I'll just explain. You play as this little alien dude down here, and you start off with this ball, right? And you roll it around, and it's a sticky ball. So whatever you hit with it sticks to the ball. So you start off only being able to pick up small stuff, like spoons, bowls, household objects. But you get bigger and bigger, and you start being able to pick up people and cows and buildings. It's insane. It's really fun. And fortunately, the functionality for it is pretty simple. You have a bowl, you roll it around, you pick things up. So it's a good option for a first game. All right. So we know what we're making now. So let's jump into Unity, and I will explain the UI, because it is a little bit overwhelming at first. Let's start off with this. In the middle here is a scene. There's currently nothing in it, so it's just a bunch of empty space. What is a scene? You can think of it as a scene in a movie or a book. It's just, generally speaking, if you want to move to a different setting, or if you want to open a menu or something, you probably want to make a new scene. On the left-hand side, we'll see the scene hierarchy, which just lists all the game objects. I will be talking about what game objects are in just a moment. Down here, we'll see the project files, fairly self-explanatory, lists all of the files which are available for use in the current project. And over on the right-hand side, we see the inspector, which is empty right now, but if we click anything, it'll fill up with information. So we'll get to see that in a moment. So, I promised we'd come back here, so let's talk about what game objects are. So, over here we see the main camera and the directional light. So you guys can probably guess these are two examples of game objects. So, We know that cameras are objects, we know that lights are objects, but everything in Unity is an object. So players are objects, enemies are objects, projectiles are audio, sound effects. Anything in the game has to be put into the game object. So that's the first thing that you probably have to know about game objects. Second thing you need to know about game objects is they don't actually do anything. You can think of them as empty containers. They hold functionality for you, but unless you put stuff into them, they don't actually do anything. So let's look at an example. If I click on the main camera over here, you see that the inspector on the right-hand side has folded with the components that the camera is currently holding. So let's go through these one by one and we'll see what they do. The first component that we see is a transform component, and you can see it lists the position in X, Y, Z coordinates, the rotation, which is the facing angle, so where the camera is currently facing, and the scale, so the size. So the transform component is actually a special component in Unity. Every single game object that you make has to have a transform component to tell Unity where it is. So you can generally get an idea that components are things that you put in game objects to tell Unity about them. So they list properties. The second component on the list is a camera. That just tells Unity, hey, this is a camera. It should be able to see things, so it can see the view here. The third thing is an audio listener. This just tells Unity this camera should be able to listen out for audio sources. So we will be seeing a lot of game objects and a lot of components while working on this game. So hopefully you guys can get a better idea of them as we move on. So yeah, if you need a recap, so basically everything in Unity is made up of scenes. Scenes contain game objects, and game objects contain components, which contain functionality. Okay, so that's enough talk. Let's get started on actually making some stuff. So if you remember what we want to do, we want to make a player, which is a sphere. So in order to add objects to the scene, we can just right-click on this menu over here, go down and create 3D object. In this case, we're going to make a sphere. We're also going to make a plane because we need a ground for the player to sit on, otherwise it will just be floating in midair. And if we do that, what I've done is I've made a sphere, I've named it player because that's our player object. I've also made a plane and I've named it ground because that's our ground object. I've also colored it in just so it's easier to see. So for anyone who's familiar with 3D modeling, this probably looks pretty comfortable to you guys. There's arrows pointing out from the sphere and you can click and drag them to move it around. If you don't like doing that, you can also just fill in the transform component directly to move your objects around. Alright. Okay, so we've got our object into the scene. I'm going to show you all something really cool now. If we click on this button over here, we can add a new component to our game object. And it'll open this menu where you can select what component you want to add. And we're going to search for something called rigid body, right? So we're going to add a rigid body component to the sphere. That's going to be added to the player object. What is rigid body? So rigid body is a component provided by Unity that tells Unity, hey, this object has to be affected by physics. So you can see it's added a bunch of physics-y stuff. There's mass, drag, gravity, velocity. If we run the game now, we'll see that it falls to the floor because it's affected by gravity now. And I don't know about you guys, but I thought that this was really cool, right? Without having to know any code, without adding any code at all, we now have an object that has mass, affected by gravity, and interacts with another object. So, but we need more. We probably want more if we want to make a game. So let's talk about how we can control this flow. So we want to be able to control it using the keyboard. We want to be able to move it with the arrow buttons. So what do we want to do next? As you've probably guessed, we want to add another component to give it functionality. So we're going to add this player controller, which is a custom component. This isn't provided by Unity. I've made one. So this is called the player controller component. And if we double click on that, Unity will show us some code. Well, this will open up in VS Code or your code editor of choice. So I did say at the beginning of the speech, we won't be looking at too much code today. This is the only snippet I put in the talk, so you won't have to look at anything else. I just want to show it up on the screen so you guys can get an idea of what I'm talking about, visualize it when we move on. So, player controller is a C# class. It inherits from Unity's monoBehavior class. What does that mean? Monobehavior gives you access to Unity's event functions. So these are provided by default, the start and update event functions. So what is an event function? What do they do? Let's talk about that next. So Unity games have a life cycle, right? And as the game goes through the life cycle and certain events are triggered, it will call the functions attached to those events. So as you might guess from the name, the start event is called as soon as the game is started. So if you put any code in here, in this start function, it will get code when the game starts. Update is an event function that's attached to re-rendering the frame. So whenever the frame is re-rendered, whenever the screen is updated, this gets code. This will usually be about 60 times a second or more for certain machines, but you can imagine it just as a loop that's constantly being coded to update the game state. So Unity has a bunch of these functions, right? Like, there's too many for me to go over, but I'll go through a few more examples so you guys can get a better idea. There's also on-application quit, which is code when the game is closed. There's also events that respond to user input. So if the user clicks or moves the mouse around, it'll trigger these on-mouse family of events. Alright, so we know what events are. Okay, that was a lot. Next, let's talk about how we can use events to move our ball around. Right, so what do we want to do? When the keyboard keys, when the arrow keys are being held down, we want to alter the state of the ball. We have access to the start and update event functions, so what do you guys think we should use? No? Mary?
I think we should use update.
Yes, exactly, you're a genius, I love you. So, the update, if you guys remember, the update is a loop that's being constantly coded. So what we want to do is every time the update is code, we want to check, is an arrow key being held down? If the left or right arrow keys are being held down, we want to rotate the ball. If the up or down arrow keys are being held down, we want to push the ball forward or move it back. So if we run the game, whoops. This is what it looks like. So it's not exact, well, it's good that's moving, that's a win, but it's not exactly what we want, is it? It's flying right out of the viewport. We've forgotten to update the camera position. So we can actually put that in the update function, but Unity also provides an event function called late update. This is just run right after the update function, and what we can do is after the player position is updated, we want to update the camera's position. And what does that look like? We run the game, we've got a moving object and a moving camera that follows it around, so that's a great win. So I'm happy with that, but it's not much of a game yet. Okay, so if you remember the gameplay of Katamari Damacy, we want to be able to pick up objects when the ball runs into them. So let's add some objects to the scene for us to pick up. This same procedure as before, we're going to right click over here, create a 3D object, and this time we're going to make some cubes to pick up. And these are our victims, which we're going to be running into. A few things to note, I have changed the size of these by transform because we do want to take that functionality of only being able to pick up small things until we get bigger and bigger. And also, game objects can have a tag attached to them. So I've made these tags pickupable. And you can use tags to make game objects a little bit easier to sort and search. So, up until now we've used update and late update, which are continuously running in order to continuously update the player and camera position. Next, what we want to do is we want to look for an event that triggers when the player runs into another object. Luckily, Unity provides something specifically for this scenario. It's called onClosAndEnter. As you can probably guess from the name, this is an event that's called when the parent object runs into another object. So, now that we know what event we want to use, the logic is pretty simple, right? When the player object runs into another object, we want to check whether it's pickupable, and that includes checking its size. If it is pickupable, we want to attach it to the player. So if we run the game now, we'll see that you can move the player around. If it runs into a medium-sized cube, it can't pick it up because it's too big. If it runs into a small cube, it can pick it up. Yeah. And once it gets big enough, it can start picking up the medium-sized cubes. So obviously it's not obviously it's not pretty. It's pretty rough, but you can get an idea for how easy it is to mock up the basic functionality for your game. So that was pretty painless. I hope everyone agrees that it's pretty easy. Okay, we spent a lot of time in Unity, so I'd like to take a step back and talk about where this talk is going, right? Oh, yeah, awesome. Great, it's a win. You've got to celebrate your wins. Okay, so next, we want to talk about adding a main menu to Unity and getting networking in so we can have multiplayer rooms. So I'd like to talk a little bit about how networking works in Unity. Okay, so Unity has a networking solution called UNet. So this is a networking stack that gives you access to networking functions like connecting to LAN, connecting to servers. They even offer cloud hosting, at least they used to. So in August of 2018, Unity announced that UNet is getting deprecated. They are stopping support for it. They said that they will be replacing it with a new networking solution, which is going to be, more performant, better implemented, and they said it should be available by end of 2019. So it's now 2020. You can probably see where I'm going with this. Where is Unity's new networking solution? Unfortunately, no news yet. But fortunately for us, we have third-party libraries. There's a lot of these available online that you can look up. But they basically provide you a networking solution so you don't have to code everything from scratch yourself. So there's a lot, but today we'll be using Photon because it has huge support, lots of people using it, and more importantly, it's free on the Asset Store. So if you look it up on the Asset Store, you should be able to find it here. Okay, so we've added this to our project. What do we want to do next? We probably want to make a new scene so that we can add in a main menu. So we right-click down here, create a new scene, and we can, this probably looks familiar to you guys, just the default view for a new scene in Unity, and we're going to add an empty game object called lobby controller and add a script to it so we can get started on our main menu. Okay, so we're going to be making a GUI, which is a graphical user interface. Up until now, we've been using the update function to continuously update the player's position. So you might expect that to be able to continuously render and re-render and update a menu, we might be able to use update. But unfortunately, you'd be wrong. Unity has a special event called onGUI, which is similar to update. It's called several times a second, but it's specifically for GUIs, and it gives you access to special GUI functionality. So if we use this, I actually grabbed a package off of the Asset Store to make a main menu that looks like this. And yeah, if you look at this, you probably have a better idea of where I'm going with this, right? The players should be able to enter the name. They should be able to enter a new room name and create a new room if they want to. And if a room already exists, you want to be able to click this button here to join it. Right, so we have the framework for a menu, but it's currently not doing anything. We want to add some functionality to it. So how do we do that? Okay, so the next steps are going to be pretty intensive, so I've made a to-do list. Just to hopefully make it a bit simpler. First thing we want to do is connect to the Photon servers. So as you might expect, this can be done immediately in the start function. As soon as the game starts, we want to connect to Photon. Next, we want to join the lobby. But we can't join the lobby until we know that we've connected to the server. So how do we know when we're connected? Photon actually provides events similar to Unity events. In this case, onConnected to master is an event that's triggered as soon as you've connected to the server. So once we've connected to the server, we join the lobby. We want to display the rooms in the GUI. Again, we use a Photon callback for that. So once we get the updated room list, we want to update the list of rooms. And when a room is clicked, we want to join the room. So we use our Unity's inbuilt onClick event in order to join a room. And if that's a little bit overwhelming, that's fine. I'm going to recap all of this right now. Okay, so everything that we talked about today, let's go over it quickly. So firstly, we did a player controller to set all the player handling. So we use Unity's update and late update events, which are constantly running to update the player and camera's position. We use onClose and enter, which is triggered when the player runs into another object to pick up pickupables. In the lobby controller, we use start, onConnected to master, and onRealList update to connect to the server. Don't have to worry too much about this process. We use onGUI to update the menu, and we use the onClick event in order to join a room. So what does that look like? It looks like more than this. What's going on here? Not loading. Here we go. Okay. That was the Wi-Fi. Okay, so we have two clients. We can join the room on the second client. You can watch the ball rolling around on the main client, and when it rolls around, you can see it picking up objects. So obviously it's not pretty yet, but that's what the Asset Store's for. So I hopped over into the Asset Store and I downloaded a bundle of 3D models, and it looks like this now, which is much better than what I had previously. So this is actually available to play on Heroku if you're interested in playing it. It does work for mobile, hopefully. So but it does have a 20 player limit. So if you can't connect, that's probably the reason why. So I'm going to change up the slide. We have got that QR code. Oh, no. Yeah. Okay. So this link is also available on my GitHub repo, which is this QR code here. This one's from my GitHub repo. So if you missed the previous slide, you can find the link here as well. Right, so my GitHub repo also contains links to the packages and references that I use, so I highly recommend checking it out. Alright, so that's it for me. Thank you very much.
Game creator here. So feel free to talk to her about over anything, Unity, the opinion, game of her choice.
Archives.
And yeah, she has a lot of opinion on games, especially like choices of games. So yeah. Meanwhile, we will take a break. We shall resume at 4:30. The last talk in this room is also about a game. So you'll be learning building a retro game in JavaScript and HTML. And please come back at 4:30. Thank you very much. Oh, sorry. Please come back at 5. last but not least, we have Mary Sedaris talking about the hero of JavaScript, recreating retro games using JavaScript and HTML canvas. And welcome, Mary!
Oh my god, I'm gonna laugh too hard to give this presentation. Hello everyone! Thank you so much for coming to my presentation. Today, we're going to talk about how to recreate your favorite retro games using nothing more than JavaScript and HTML canvas. So, a little bit about me. I've got kind of a weird background. So 3 years ago, I came to Japan to do a master's degree in history at the University of Tokyo, where I studied Cold War spies in Japan. If you're bored, feel free to ask me questions after this presentation. Not during it, please. After I graduated, I ended up leading digital marketing at a small Tokyo tech startup that we're actually standing in right now. And right now I'm aiming to be a software engineer, and I am having a really good time building things with React, Material UI because I have a very basic sense of design, and C# with Unity, kind of like what Sarah just presented on. So, I just introduced making games with JavaScript and HTML canvas, but what kind of games can you build? Surprisingly complex ones. Back in 2015, a software engineer ended up recreating Link's Awakening entirely in JavaScript and HTML and CSS. He used jQuery, so it's a bit more complex than what I want to get into today. So, what we're going to build is this really cute, lacking collisions, glorious top-down 2D RPG in the style of Zelda. I also had to switch all of the sprites from Zelda sprites to this, so apologies, just imagine Zelda in your mind. So, when it comes to building JavaScript and HTML canvas games, what you're going to see immediately pop up are these frameworks online, and these most popular frameworks are Phaser 3, Pixie.js, Melon.js, Kiwi.js. There's a lot of them, and they're really useful for making complex games that look really good in your browser. However, today, we are not using these. We do not want it to be complex, and we do not want it to look good. The reason that I'm not using these is one, I want you to understand not just the how of what you're doing, but also the why. Also, I want you to have a really easy time setting it up. Back 2 years ago, I tried to use Phaser. I knew nothing about programming, and setting it up was a complete nightmare for me. Finally, my computer's really old. I don't know how much she can take, so we're gonna go easy on her today. So, we are going to cover today 5 different aspects of a game in the browser. Building your first environment, making your hero move, using sprites and sprite sheets to make it look almost as good as if you're using a framework, implementing collisions, and then also creating a basic form of interactivity. So, let's get right into it. Let's create our first environment. What do we need to do? Well, first, we need to set up HTML canvas. So, if you were following along with me on your computer, I would ask you to create 2 files, an index.html file and a game.js file. And I would have you link to that game.js file inside of your index.html. We're going to be making no more files. This is literally all you need to get started. As I said, very simple. Next, we're going to actually create a canvas. And in JavaScript, in the game.js file, if you want to build a canvas, all you have to do is use document create element. Really simple. We're going to specify a width and a height, and finally, we're going to append it to our browser. So really easy stuff. Next, this is the most important part of working with HTML canvas, because if you don't do this, nothing's going to show up. You need to create a context variable, and we're going to set this context variable to 2D because our canvas wants to know, do we want to build something 3-dimensional or something 2-dimensional? Today, just 2D. This context is going to allow us to actually draw on the canvas. And now, how do we make a good looking environment? Because right now you would just see a blank white space. Well, you're just going to find an image you like. It could be anything. It could be like a photo of New York. Genuinely choose what you like. Please don't steal from any artists. There's a lot of free resources out there like opengameart.org. And once you choose your favorite image, just create an assets folder alongside your index.html and your game.js to store all of these images that you're going to be using. So, when you want to actually make this image that you've chosen appear, it's actually a really simple process. All you're going to want to do is you're going to want to first create a new image. I've just called it here on line 13 background image because straightforward, simple. You're going to want to create a background ready variable and set it to false. Now this is going to be set to true on load, and I'm going to explain why this is important in just a moment. So, our load image is going to be the function that actually brings these images to life in your browser. So basically, if our background ready is true, if our image is loaded, then we are going to use something called context.drawImage to actually draw it onto the canvas. Finally, and this is the last bit of major setup we're going to be doing, you're going to want to create a game loop function that is going to be loading your image repeatedly using requestAnimationFrame. You are also going to call your loadImage function inside of it. So, I've been saying drawImage, I've been using it alongside context, but what actually is drawImage when it comes to HTML canvas? Well, there's two explanations actually, and we're going to be using both of them. So this simple explanation is, drawImage is what you want to draw on the canvas, and where on the canvas you want to draw it. The more complicated version that I actually had to scale down because it's too large to fit on the screen is this really long thing that not only takes the image that you want to draw, but it also extracts parts of that image using source values that you give it, and then puts those extracted values onto your destination canvas exactly where you specify and exactly how large you specify. This complicated version we are going to come back to because when it comes to working with sprites, you need to be very complex. Also, remember how I said you could choose any background image you like? Try to make sure it's the same size as your canvas, or else you get kind of fun bugs when you go off of it. Yeah, Link is duplicating. So, you just saw that we have a moving character. Let's actually build this. He's going to move a little bit better than that little bear guy. So, it's exactly the same as what we did with our background image. You've already done it once, you can do it again. The only difference is that now we want to create a hero object. And inside of the hero object, we want to give it values of speed, which I've set to 3 because I don't like going slow, I kind of prefer moving quickly, and then x, y variables. And you'll notice that we've also said if hero is ready, which is the same as background ready, we're going to want to draw it to certain coordinates. And the coordinates for our hero are decided based on the coordinates inside of the game object from lines 32 to 36. So, he's here, and he's at point 0, 0 of the canvas. You can see him right up in the upper left-hand corner. Super cute, we're gonna work with him. So, how do we make him actually move now? It's really simple. All we have to do is create an empty object that we can call keys down, or whatever you'd like, and then we want to create event listeners for certain actions. So the first is a key down listener, which is going to check for if a user is pressing a button on their laptop or computer, and the next is a key up, which listens for when our user releases that. If you're pressing on a key, it's going to be added to the object. And as soon as you release that key, we delete it. So really, really, really simple. Now, it looks scary. There's a lot of code, but I promise you it's very easy. What we're going to want to do is create a move hero function that actually acts on this. So, you'll see in the first line, lines 70 through 75, this first if statement. Basically what we're doing here is we're checking for if a person is pressing the up arrow key. And if they are pressing the up arrow key, then we're going to call this function move character, and we're going to feed it these kind of mysterious numbers. Don't worry, I'm going to explain that. Basically, our move character is what actually makes our character move, like you'd imagine given the name. And you'll see that what it's taking in on line 95 looks kind of complex. In fact, these delta x and delta y, all they do is make sure that our hero is going to move at a steady pace, regardless of frame rate. And once we've created our move character function that's being called inside of our move hero function, we can just call move hero, our overall function, on line 110 inside of our game loop. And now this is what's going to make our hero actually move. And look, Link can move wherever he wants on the screen. And also maybe he can move a little bit too much on the screen. But before we get into collisions, I want to talk about sprites and sprite sheets, because right now I've been using Link, which does not belong to me as much as I love him. So we're going to use our own heroes. So remember how I said we need that complicated version of draw image to work with a sprite sheet? This is it again. We're going to be giving it these source variables that are going to tell us what sprite we want to draw and where we want to put it on our canvas. If you don't use source variables, then your entire sprite sheet is going to appear on the screen, which is kind of cool, but I don't think we want that. So, what are the basics of a sprite sheet? First of all, a sprite sheet, as you'll notice, is this one image file, and inside of it, it has basically each step of an animation drawn out. And you can actually use these different steps by specifying values on either an X or Y grid. The real values that you're going to put in to access these images are based on whatever sprite sheet you're using, so it's going to change. So the sprite sheet that I want to use, as you might have seen before, is this. I think he's super cute. He's 16 pixels wide and he's 32 pixels tall, so let's keep that in mind. So our X value, as you might notice, our horizontal grid, is going to be our position in the walk cycle, whereas our Y value is going to decide what direction our hero is facing. Keep this in mind, it's going to be very important very soon. So, in practice, if I want to load the hero image, and I want to get the very first position, and I just want to get something that's 16 pixels wide, 32 pixels tall, and I want to just put it to the first position on my destination canvas at the same size, I would do a very long function like line 1, and I would get this result. If I want to move more through the walk cycle, so on the X grid, then all I have to do is actually increase the X value that I'm giving to draw image. So you'll notice that in number 2, it's not 0, it's 16, because we're starting at 16 pixels. Now, if I want to move down, rather than through the walk cycle, if I want to change direction, all I have to do is change the Y variable to 32, because he's 32 pixels tall, right? This is scary. This really scared me when I was first learning, so don't worry about it. Basically, these are your results from these functions. So, a lot of code has just appeared here. We're going to start with the pink box, and we're going to create a walk cycle, which is an array that holds values. Can anyone guess if the walk cycle is the X or Y grid? Sarah, you yelled at me. Sarah, do you have an answer? You're perfect, yes. This is going to be what we feed as our X value because we're moving along the horizontal grid to different positions in the walk cycle. We're just going to have walk index 0 because we want to start at the beginning of the array. Next, remember how draw image wants a source width and a source height. We can just define those in variables on lines 72 and 73, so that way we don't have to rewrite it every single time. We want to make things easy for ourselves. you can basically ignore everything else except for the red box, which is basically everything else. And in the red box, we're defining a function called drawFrame, which is a simplification of our drawImage call. So basically, all you need to give drawFrame, you don't need to give it a hero image because we've already defined that in the function. All we have to give it is which X frame we want, which is going to be 1 for, like, let's say 0 to 16, 2 for 16 to 32, and so on. And we have to give it a Y frame, which is exactly the same. It's just a number that's multiplied by the width or the height of our sprite. And then we're going to define where we want to put it on our canvas. It's that simple, and it's going to make your code so much easier for you to read if you choose to follow this. Next, we're going to create a, oh, that's depressing. I guess that my computer just decided it didn't want to keep presenting. We're going to be creating a variable next. That should not be too bad. Yeah, I think that maybe it disconnected from the projector.
I get the signal, so it's something.
You're
with
getting the
projector.
signal?
Yeah.
Sorry, everyone. I think that so many variables made the projector just I know how it feels, honestly.
And you thought your computer would give up.
I know. Honestly, this thing is like 5 years old. I was expecting it to be the problem. It's starting? Yay! Everyone in the audience, if anyone were to go boo, then I would feel like I understand.
Yay!
Play off nights. Has anybody heard of the mobile game Arc Knights? No. I'm noticing some blank faces. Okay, never mind. We aren't going to talk about that yet. Okay, it's warming up. Can everyone in the front see this fine? People in the back, is it kind of okay? Alright, in which case, this is kind of the last section of how we're going to make our sprite move. We want to create a hasMoved variable that we automatically set to false, and this is going to allow us to go back to an idle animation if we are not moving. Otherwise, we would just like keep on walking even if we're not actually moving. So it's important, I promise. And next, we're going to want to set it to true if someone actually presses a key. So you'll see from lines 128 to 132, in line 131, we're setting it to true. This allows us to start moving through our animation. So, as you can see here, there's this very long thing. In line 163, what I want you to pay attention to is if we have not moved, we're setting it to 0, our basic walk cycle idle animation. And if we have moved, then we're going to want to keep on looping through our walk index, which, as Sarah said before, is our position on the X grid. Finally, we created this glorious drawFrame function, so we're going to want to give it as its X value, our walk cycle in its certain index. We want to give it as a Y value 0, because we are not changing direction yet, and then we want to just make this appear at our hero's coordinates. And oh no, what just happened? So, remember how we created a load images function earlier on? If we do not get rid of our draw image of our hero in that function, this is what happens. Honestly, if you want to keep it like this, that's fine. I don't. So we're just going to switch to this. We've deleted that line of code now. So, time to change direction, because this is kind of creepy. He's just staring at us. So, remember how I said we have those great Y coordinates that allow us to change direction. So I've added the sprite sheet so you can see what it looks like. So when he's facing down, that's 0, of course. When he's facing up, that's actually going to be row 2. When he's facing to the right, row 1. And when he's facing to the left, row 3. And I'm just going to set our current direction automatically to down. So, remember how we were just giving move character like true as the third value? now we can make that actually functional, and we can give it a direction. So now, depending on what arrow key you're pressing, I want our hero to change direction. And inside of our moveChar function, it already sets the hero's current direction to whatever the third value we give moveCharacter. So we don't need to worry anymore. And now, he can change directions! Isn't it exciting? Career ballerina. Can just twirl. All right, now for the really complex section, guys. Collisions. And honestly, it's just this slide, so I lied. So if you want to make collisions, it's not even an extra line of code. It's just an extra ampersand in a single condition. All we are checking for is on line 182, after the two ampersands, you see a hero.x and scaled width, so however wide he is on our destination canvas, plus our delta x is less than the canvas.width. Then we allow him to move. So basically what we're saying is, if the hero image is not clipping outside of our canvas, we're going to let him move. And now, we can't escape. He can't walk off the canvas anymore, he's trapped. I hope we chose a good environment for him. And finally, this is what you've all been waiting for, interaction. And actually, interactions are going to use collisions as well. So, first, we want to make some cash for Link to pick up, or our hero, pardon me, Freudian slip. So, we need to create a rupee image, and all that is just gold, basically, except it's a gem. It's really pretty. We're going to define a rupee object for it as well, and you'll see that it appears at 0.00 as I specified, but we can't do anything with it. It's kind of depressing, honestly. It's just looking at it. So, first of all, you might have noticed another problem with this image. If it just stays here, and I want to game the system, then I can just stand on top of it and get rich forever. So we kind of want to avoid that, as fun as it would be. So we want to create a generate function that will randomly generate our cash, or our rupee, across the canvas. And all this is going to do is just use math random, as you'll see in lines 148 and 149, to throw the rupee to different locations across the canvas. And how do we make generate actually work? Well, we want to call it when our hero collides with the rupee. So basically, you'll see the same really basic collision we just did in the previous section. We're just going to do it again. If our hero object overlaps with our rupee's object, then we throw the rupee to a new point. However, something went wrong. If you're like me, when you create a function, you want to call it immediately. So, I called it outside of collision as well, and this is what happened. I'm not sure if it's a game feature or a glitch, but it's certainly fun to watch. So, once you get rid of that extra generate call, we can now chase cash across the canvas. And I maybe should have named this talk The Hero of Late Capitalism, because it's a kind of depressing main game mechanic. So, what have we covered today, everyone? We have displayed a simple environment of our choice. We have moved a hero across our HTML canvas. We are working with any sprite sheet we want. We've implemented collisions. We've created interactivity with cache, but you could do better things, honestly. And we've also looked at all of the things that go wrong in code. The challenges for me was finding resources to actually make this. I don't know why, but everyone using vanilla JavaScript loves side scrollers and not top-down RPGs. Poor taste. Not good taste. The other issue was running into a lot of glitches, some of which I have not shown you. And I'm going to be publishing this, so if you want to create your own game, these are resources you can use. Feel free to find it at my GitHub repo, which you can find at this QR code. Thank you for listening, everyone.
Thank you very much, Mary. You reminded me a lot of my childhood memory. Yeah, my grandmother is a retro gamer. She has like all the photos Nintendo, NDS, whatever. I can't even name the machine, so yeah, I grew up with her playing retro games, and yeah. So, thank you very much for coming, and this is the end of Big MiniConf today, but, mark your calendar, on March 26th, Thursday evening, it will be our demo day, and all of our speakers today will be presenting their senior project, which is a graduation project. And I can't wait for time to come. So please mark your calendar once again, March 26th, Thursday evening, same place in Cook Chrysalis. Thank you very much for coming, and please talk to Mary for anything.